Good day, students. You're welcome to this class. Today we'll be discussing probability, and under this, we'll be talking about experimental probability. I would like you to get your writing materials ready. Since this is mathematics, we have to do a lot of writings. Okay, definition of terms. Probability or chance. That's to tell you that another name for probability is chance, and it is a measure of the likelihood of an event happening or not happening. And I believe every one of us must have heard this word probability. What is the probability that it's going to rain today? What's the probability that I will go out today, and things like that. And it is also important for us to note that our values in probability are always between 0 and 1. You cannot have a negative value in probability. It's not going to be less than 0. You cannot have a value less than 0. Neither are you going to get any value greater than 0. But when you are very sure that an event will happen, that is the one we call certain. An event will definitely or certainly happen in a given probability. So when it is certain that the event will happen, then it is 1. The probability of that event happening will be 1. For instance, what is the probability that New Year will be January 1? The probability is 1 because it is certain. We are very sure that the new year will be January 1. Do we get that? So, another thing that we have is impossible. Impossible. That is probability that you are very sure that this thing will not happen. And the probability is 0. What is the probability that you as a human being will eat plastic as food? You will see that it is 0. Plastic is not food, so you cannot eat plastic. It is impossible. So the probability is 0. Do we get that? Now, even the probability of half or 0.5 means that there is 50-50 chances that the event will happen. There are 50-50 chances that the event will happen. For instance, a pregnant woman, we know is going to deliver a child. Now, what's the probability that the child is going to be a boy or a girl? So you will see that it's either she give birth to a boy or a girl. So that is half. The probability of even is always half, 1/2. Another instance is a coin. When you toss a coin, what's the probability that you will get the head or the tail? The head that we are talking about here, for a coin, you will see one part. If you're using 1 naira coin or 2 naira coin, the first part is a head that is drawn on it, while the second part, another thing can be drawn on it. So we are going to be considering the part that is drawn with head as our head. So what's the probability that when you toss a coin, you are going to get the head? So you will see that when you toss a coin, it's either you get the head or you get the other side of it, which we call the tail. So the probability of tossing a coin is even. It's either you get a head or a tail. So the probability of getting a head is half, and probability of getting a tail is also half. Then we move to likely. likely. When probability tends to 1, then there is likely chance that the event will happen. Probability tends to 1. Remember, I told you that our values will always be between 0 and 1. Now, if the probability is, let's say, 4/5, you see that it's tending to 1. It means that it is likely to happen. Take for instance, in a family, they have let's say 4 boys and a girl. The first son get married and gave birth to 4 boys and a girl. The same up to the fourth child. Now, what's the probability that the 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 firstborn gave birth to 4 boys and a girl, the second born 4 boys and a girl, and the third born gave birth to 4 boys and a girl. The fourth one gave birth to, let's say, 2 girls and a boy. Now, what's the probability that the fifth child will give birth to 4 boys and a girl? You will see that the probability that it will happen is higher, because in that family you will see that most of them are giving birth to 4 boys and a girl. Is likely to happen. So probability of unlikely, that's when the probability is tending to 0. When the probability tends to 0, then it's unlikely that it will happen. Now, what's the probability that it will rain in February? I'm not going to say that it's not going to rain at all in February. We know it's dry season, but we see that we have low chances of it raining, so it's unlikely. Not really impossible, but unlikely to happen. The probability tends to 0. If you check the number of rains we have January, February, you will know that it is tending to 0. You cannot compare how it rained in January, February to how it is raining in the month of May, which we are in now. I hope we understand what I've been saying so far. So now, what is probability itself? How do we calculate probability? We will see that probability is number of successful outcome over total number of possible outcome. Number of successful outcome over total number of possible outcome. Remember, when I said a woman is pregnant and gives birth, and I said that the probability of having a boy is 1/2. The successful outcome is a boy, which is 1 out of the 2 sexes that we have. The total number of possible outcome is 2. That is, it's either the woman has a boy or a girl. That's 2. So probability will be number of successful outcome over total number of possible outcome. So that will be 1/2. Probability of a woman giving birth to a boy is 1/2. I hope we understand what I'm actually saying before I move to the next. Then we are going to consider these examples. Example that we are seeing here. A die is rolled 200 times. A die, when we're talking about die, you know dice, Ludo die. 1 is called a die. When it is 1, it's die. When it is more than 1, it is dice. right? So a die, now we are rolling just one. Most often when you are playing Ludo, you use 2 dice. But for this particular question, we are using just 1 die. A die is rolled 200 times. The outcomes obtained are shown in this table that we are saying. We can see the number and the number of times. On a die, that we have 1, 2, 3, 4, 5, 6 sizes. The side. I want to believe we are familiar with playing a Ludo game. I actually promised us that if school resumes, when we are going to take this probability that we are going to play Ludo game, and we are also going to play card. But as it is, when school resumes also, for those of you who did not know what a die is, and we are going to be showing the die to us. So it has 6 faces. Now when it is rolled for 200 times, we're able to obtain 25 1. Like the number of times we get 1 happen to be 25. The number of times we get 2 is 30. Number of times we get 3, 45. The number of times we get 4 is 28. The number of times we get 5 is 40. And the number of times we get 6 is 32. Having known this, the question now is, find the experimental probability of obtaining A2. Find the experimental probability of obtaining A2. So, looking at it, you will see that how many 2 do we have? We'll come back to the table. So the probability of obtaining a 2 will be, come back to the table, how many 2 do we have? The number of times a 2 appeared is 30. So that is our successful outcome. Don't forget that our probability is the number of successful outcomes over total number of possible outcomes. Are you getting it? Number of successful outcomes over total number of possible outcomes. That's our probability. So the number of successful outcomes we are talking about here for 2, how many times did 2 appear? That is 30 times. That's the number of successful outcomes, 30, over total number of possible outcomes. How many times was this die rolled? It was rolled for 200 times. So this is going to be the probability of obtaining a 2 will now be 30 over 200. So when you reduce this to lowest term, if you want to reduce this, you will see that this 0 cancel this 0. If you have this 0, cancel this 0. All we have left to be 3 over 20. So you can leave your answer in fraction like this. You can leave your answer in fraction like this. That's 3 over 20. Or you can convert it to decimal. So this 3 over 20 is the same as 0.15 rather. So you know the process of converting to decimal. You can use your long division or you can use calculator to convert this. So the second question is to find the experimental probability of obtaining A5. The same thing that we did here is what we are going to do here as well. The probability of obtaining A5 will be, how many times does 5 appear? Our 5 appeared 40 times. It appeared 40 times. So that would be the total number of successful outcomes is 40. And the total number of possible outcomes we already know is 200. So that will be 40 over 200. If you reduce this to lowest term, we have 1 over 5. which is the same as 0.2. Do we understand? I do not want to be too fast. All right, let's proceed. I believe you understand, but if you don't, um, just pay attention to the third example and you will get it because it's still the same procedure. Now, the probability of obtaining a 6. The probability of obtaining a 6. You look at it, how many times the 6 appear? It appeared how many times? 32 times. So our successful outcome is 32 over total possible outcome, that is 200, right? So the same way you reduce it to lowest term, right? You should know how to reduce it to lowest term, and then you can leave your answer like I've said in fraction, or you take it to decimal fraction. I hope you understand that. So let's consider this next example. It is still experimental. Don't forget, it is experimental probability. All these things are things you can actually experiment. You have dice, you roll out your dice. You know, the more you are rolling your dice, you discover that you're not going to be getting the same value. It has 6 faces: 1, 2, 3, 4, 5, 6. So when you are rolling, you can get different values, right? So it is experimental probability. Now, let us consider this next example, our example 2. You see, it is known that in a certain country, out of every 3,000 people, 20 died between the ages of 30 and 40, right? In a certain country, they have already known that out of, when you sample out 3,000 people, 20 out of them will die between the ages of 30 and 40. They don't live beyond 40. They die. Out of every 3,000, 20 of them die between those ages. Now, what is the probability that a person will die between 30 and 40 years? Now, to solve it, do not forget our formula, because if you forget the formula, you will not be able to get it. Don't forget that our formula, probability is equal to number of successful outcome over total number of possible outcome. So the probability that a person will die between 30 and 40 years will be, how many people die between that age? That's the successful outcome. How many people die between the ages of 30 and 40? We discover that there are 20 people. So the successful outcome is 20 over total number of possible outcomes. How many people altogether we are sampled? 3,000. So it will be 20 over 3,000. Reducing this to the lowest term, we have 1 over 150. Do we get that? I trust we understand that. So, looking at more examples here, in an experiment, a dice, here, dice is used instead of die. A dice, we are still talking about one die, is thrown 500 times. You know, this will help us to understand more the first example that we have done, right? Is chose or thrown or rolled. Any of those words can be used 500 times. So the table below shows the outcome, discussed, that's the numbers We already know that a die has 6 faces. A die has 6 faces. So that is 1, 2, 3, 4, 5, 6. So the frequency, how many times did each of these number occur? You see that our 1 appeared 84 times, 2 appeared 81 times, 3 appeared 88 times, 4 appeared 85 times, 6 appeared 82 times. So find the relative frequency of getting a 5. I trust we can even solve that before I start explaining. The relative frequency of getting a 5. That is, find the probability of getting a 5, right? And a multiple of 3. A multiple of 3. We also asked to find the relative frequency of getting a multiple of 3. Then the next question is find the relative frequency of getting a 3. A multiple of 3 and a 3 are not the same. They are different things. Now the last question there is, how many times would you expect to get a 3 if a dice is thrown in a total number of 2,000 times? Right? So that's the question. Now let us consider the solution. Right? The relative frequency of getting a 5. How many times did 5 occur? That's our number of successful outcomes. How many times does 5 occur? That's 80 times. Our 5 occurred 80 times. So, and how many, the total possible outcome, how many times was this dice thrown? It was thrown for 500 times. So the relative frequency of getting a 5, or the probability of getting a 5, is 80 over 500. Right? So reduce this to lowest term. We have 4 over 25. You can see here the answer is left in fraction. If you so wish, you can convert it to decimal. Right? The second question is a multiple of 3. Find the relative frequency of getting a multiple of 3. So, multiples, I believe we know multiples. This is senior class, so I believe that there's no one of us that do not know multiples. But if you don't know, multiples of a number are numbers that can be divided by that same number without remainder. Say for instance, multiples of 2, we have 2, 4, 6, 8, 10, 12, 14, 16, and so on. You will see that all these numbers that I listed can be divided by 2 without remainder. So they are the multiples of 2. Now the question here is, we should find the relative frequency of getting a multiple of 3. And the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, and the likes, and so on. So, multiples of 3 that we have here is 3, are 3, and 6. They are the multiples of 3 that we have here. So, we will be adding the frequencies of 3 and 6. So the frequency of the event, how many times did 3 appear? 88 times. How many times did 6 appear? You can see that it appeared 82 times. 6 appeared how many times? 82 times. So when you add these things, 82 plus 88, that will give us 170. So if that is the case, if it's giving us 170, then the relative frequency of obtaining a multiple of 3 will be this sum, this value, which is 170. That happened to be our that is our successful outcome, 170. Then the total outcomes, the total possible outcome remain 500. So 170 over 500, that gives us 17 over 50. Do we understand? Am I being too fast? Please, I would like to get feedback. If I am being too fast, you let me know, so that in our next videos we try to be slower. And if I am being too slow, let me know, so that in our next video we try to be faster. All right. Okay, now let's continue. The next thing is how many find the relative frequency of getting A3. You know, the previous one was multiple of 3. Now is probability of getting A3, right? So the probability of getting A3 is just how many times the 3 appear. That's our number of times they appear, successive outcome. Successful outcome is 88 times. And the total possible outcome here still remain 500. So you can reduce this to lowest term, or you can convert to fraction as it is done here, right? So the last question here is, how many times would you expect to get A3? How many times would you expect to get A3? If the dice is thrown a total number of 2000 times, don't forget that the probability of getting A3 is the probability of getting A3 is 0.176. So for you to know how many times A3 will appear, if this die is told for 2000 times, it will be the probability that you have got times 2000. So to know the number of times we are going to get A3, if it is thrown for 2000 times, it will be 0.176 times 2000. If you want to know the number of times A5, you can get A5. If it is thrown for 2000 times, it will be 4 over 5 times 2000. Since 4 over 5 is the probability of getting A5. Are we getting it? Yes, I trust we are getting it. I trust we are getting it. But if you are not, don't forget to make your comment, that I may know where you are not getting it, to improve on our videos next time. Okay, now we have a pack of playing cards. A pack of playing cards. Remember I said that we are going to play this card. We are going to play this card, right? Knowing how to play the card will help you to answer any question that come out of it, because you would have mastered how many diamonds, how many clubs, how many hearts, how many spades we have, how many kings, how many queens, how many jacks. So notwithstanding, we are going to explain it, but anytime we meet, we are likely, let me use the word likely, we are doing probability, so it's still going to be, it's still under probability. Now we're going to play the card, it's still other probability. Don't come and hold me responsible. That you must teach us. It's alright. Now, a pack of playing cards. Here, a standard pack of 52 cards. That means in a pack of playing cards, we have 52 52 cards. What that is telling us is that the total number of required outcome when you are told a card is selected from a pack. So a pack always have a pack of standard cards always have 52 cards in them. It's very important you know this. It's very, very, very important we know this. It has 52 cards. So a standard pack of 52 cards has 4 suits and each one contains 12 cards. Each suit has 13 diamonds. 13 clubs, 13 hearts, and 13 spades. The diamond, this is how you know it. In fact, the face of this card they are showing us is diamond. This is diamond. The diamond. If you bring out your cards, your pack of cards, and you count the cards, you will see that you have 13 diamonds there. The clubs are also 13, the hearts are 13, and the spades are also 13. So when you add it, 13 diamond plus 13 club plus 13 hearts plus 13 spades, it will give you 52 cards. So definitely we have 52 cards. So now there are 28 red cards. Sorry, there are 26 red cards and 26 black cards. You know, when you have the card, some are red, some are black. Those of you that already played the card, you would have noticed that we have 26 red cards and 26 black cards. The diamond and the heart are both red. The diamond and heart, please don't forget, the diamond and the heart are both red. Don't ever forget that. The red cards are the diamond and the heart, the diamond and the heart, the diamond and the heart, the diamond and the heart. You see, I'm reciting it so that you don't forget. The diamond and the heart, the diamond and the heart. They are both red. Because you may be asked, what the probability of drawing a red card? What's the probability of drawing a red card? We should know that it's 26 over 52 because the number of red cards, which is successful outcome, is 26. And what is the probability of getting a red card if the card is diamond? You should know it's 1. If the card is diamond, then it is a red card. But if you don't know that a diamond is red, you don't know that diamond and heart are red cards, when I ask that question, you may not be able to answer it. Right? So we should be able to know these ones, that the diamond and the heart are both red, while the club and spade are black. Club, spade, black. Club and spade, black. Club and spade are black. Club and spade. You can see I'm taking much time on this slide to explain it. I'm taking much time to explain this particular slide because I really want us to get it. I really want us to get it. Club and spade are black. Club and spade are black. Club and spade black. Club and spade are black. Club and spade are black. Diamond and heart are answer now. You should be able to answer that. Diamond and spade are red. So let's move forward. Since I believe by now you should know it by heart, you should know it without checking book, without anything, that diamond and heart are red, while club and spade are black. Good. Now, for example, the cards in each suit are the same. The cards in each suit are the same. They are the same. They are the same. Cards in each suit are the same. So, for example, you have your diamond. We have A. When you are playing, the first card you place is your A. Then 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King. That means you have finished arranging it perfectly, right? Each suit has 13 cards. The diamond has A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King. So we have 4 of each type. 4 of each type. 4 of each type. So 4 times 13, that's how we get 52. 4 of each type. A. So in a pack of a card, we have 4 A's. In a pack of each card, we have how many A's? 4 A's. That is, we have one for the A, one for hearts, one for diamond, one for club, and one for spade. We just, for each of them, we have one, right? And 2, we have 4 2 in every pack of standard card. You cannot find more than 4. They are just 4. What that is telling us, for diamond, we only have just one card that is 2 for diamond. For club, we have just one card that is 2. Same for heart and the likes. So each type has, we have 4 of each of these types, right? Now, where A is ace, J is jack, Q is queen, and K is king. A is ace, J is jack, Q is queen, and K is king. Out of these cards, there are 12 pictures. How many pictures? There are just 12 pictures. How many? Just 12 pictures. Namely, 4 kings, 4 kings, 4 queens, and 4 jacks. Please do not make the mistake of adding ace. Ace is not a picture. It's not a picture. Just that instead of numbers and others, it is A that is there. But your king, you will see it there drawn. If you get a pack of cards, you will see the king drawn. You will see your queens drawn and your jacks. So they are pictures. right? So we have 12 pictures. I'm emphasizing on these 12 pictures. Some people make the mistake of saying that we have 16 pictures. That is why we encourage you, if you can get this pack of standard cards, bring them out, you will see them. You see that the A's does not have a picture drawn on it. It is either is the symbol of diamond or club or heart or spade that is on it. While for a king, you will see the king drawn there, so it is a picture. For queen, you will see the queens drawn there. For jack, you will see the jacks drawn there. So those are pictures. They are pictures, right? So now, assuming I should ask you the probability of picking a diamond. What is the probability of picking a diamond? What is the probability of picking a diamond? You will see how many diamonds do we have to start with? How many diamonds? How many diamonds? We have 13 diamonds. So, and total number of possible outcomes. How many cards are in the pack? 52, right? So if that is the case, the probability of getting a diamond will be 13 over 52. I believe you are writing because I have asked you from the beginning to get your writing material. I may not be able to write everything here, but I expect you to bring your writing materials. Like what I have just said, the probability of getting a diamond is not in this note. So you have to write it down. You have this video and you make a jot down some things that I have said that are not written in this note, what I have said there. You understand? That will help you to understand this thing very, very well. Right? Understanding is the key. Remember, I used to say that understanding is the key. You have to understand very well. Thank you. So, how many pictures do we have? I mean, we have just 12 pictures. Just 12 pictures. 4 kings, 4 queens, and 4 jacks. 4 kings, 4 queens, and 4 jacks. Okay. Now, let us consider another example apart from the one that I have said. Now, I've asked you probability of getting a red card. That's even because we have equal number of reds and black cards. We have 26 red and 26 black. So if that is the case, probability of getting a red card will be 26 over 52. That will be 1 over 2. Have to write it down, right? You need it. And what other question can I ask you there? Okay, what's the probability of getting a king? What is the probability of getting a king? How many kings do we have? We have just 4 kings. So the probability of getting a king will be 4 over 52. So reduce it to lowest term. It's always good when you reduce it to lowest term. Probability of getting a king is 4 over 52, right? So that will give us what? 1 over 13. 1 over 13. Probability of getting a king is 1 over 13. Okay, let us consider the last slide of this video, which I believe will be simple. It's just a simple example. All right, look at this simple example here. He said, find the probability of picking a picture card in a pack of standard playing cards. I actually believe that everyone should be able to do this, even if I did not put this example here, because I believe I've explained it very well to you know that we should be able to solve this, right? The probability of picking a picture card in a pack of a standard playing cards. So what we have to do first is, how many picture cards do we have? How many picture cards do we have? How many picture cards do we have? How many? Remember I said it, I emphasize on it that we have 12 picture cards, 4 kings, and 4 jacks, right? So there are 12 picture cards. So the number of successful outcome is 12. So the total number of possible outcome is 15. So you see there, probability of a picture card is 12 over 15. Reducing it to lowest term, we have 3 over 13. So I believe that you have understood this very well. There will be assignments on this. Make sure you do your assignment and submit, because I am going to grade you the assignment. Thank you. God bless you. We'll meet in our next class. Have a lovely day. Bye.